Okay, so how is everyone today? Good? All right. So how was the substitute? Liked him? All right. Glad to hear it. Let's see. Today's the 28th. Last time y'all talked a little bit about solving quadratic equations and and a little bit about complex numbers. So just to pick that up, one of the main things about this kind of idea is to say, well, what if we have two real numbers a and b? We have two real numbers. I'm trying to make it not blow out so much. Yeah. Y'all can see that in both cases, right? All right. So let A and B be in the reals. So if A multiply B equals 0, so if the product of those two numbers is 0, then A is 0 or B is 0. So if you have two numbers, you compute their product, the result is 0, then at least one of them is 0. But understand that in a math class, that means that this one is 0 or that one is 0 or both of them are 0. This is fine also. So the place where this comes up is something like this. Say, solve x squared minus, say, 17x plus 60 equal to 0. Which is to say, we want to find all the x's, so that when you plug in that x, the equation is true. So for example, at x is 0, is the equation true when x is 0? Well, the right-hand side would be 0, right? What about the left-hand side when you plug in x is 0? It'd be 60. So the equation would be 60 equals 0. So is that an equation? 60 equals 0? Yeah. Is it true? That's false. So then the relation between this equation and this idea is that this quadratic, you know how to factor it. So how does it factor? Very good. So it factors as x minus 5 multiply x minus 12. And the relationship between this and that previous statement is that, well, notice that if I just cover that up, what it's saying is that this thing on the left multiplied by that thing on the right is going to be 0. So it must be the case that either the left thing or the right thing is 0. Right? One of the things I'm covering up has to be 0. So as a result, this equation is the same as that equation. And now this kind of complicated equation, in fact, splits into two pieces. And it's saying that, well, perhaps x minus 5 is 0, or if not that, then x minus 12 is 0. So now this one equation has split into two parts, and each of those equations is simpler than the previous two. So in fact, they're really simple. So like this one, you can solve for x by moving the 5 to the other side. Good. Any question about this idea? All right. Another example to sort of show the variety of possibility. How about 4w minus 3 multiplied by w cubed minus 8w plus 12. No. So this w cubed minus 8w squared, and then plus 12w equals 0. And so the request is solve. All right. So on the one hand, note that we can just use that first rule again, like immediately, right? So that because this is one thing multiplied by another thing equal to 0. All right. So as a result, just immediately the equation splits into two pieces. So one possibility is that 4w minus 3 is 0. Another possibility is that w cubed minus 8w squared plus 12w is 0. All right, so this one on the left is sort of straightforward enough, I think. You could probably even do it in one step. What would w be? 3/4, right? 3/4 because you move the 3 over and then divide by 4. So so w is 3/4. Okay, but how do we go about doing this one? Well, let's look. We've got 1, 2, 3 terms. So there's 3 terms, and it's always a good idea when you're trying to do this kind of thing. If there is a greatest common factor, you should probably factor it out. So is there a greatest common factor?
Yes.
Yeah? So then what is the greatest common factor? W. So w multiplied by w squared minus 8w plus 12 is 0. And so, oh look, yet again, right? We've got, we can split it into parts. But I'm gonna not do that just yet. And I want to ask, well, how about this quadratic that's in the parentheses? Does it factor? Yeah, how does it factor? 2 and 6, right? So w minus 2 multiplied by w minus 6 is equal to 0. All right. So now the point of me doing this one is that well, on the statement we said the product of two numbers is 0, so one of them must be 0. And then here we did an example: the product of these two factors is 0, so one of them must be 0. But I want you to understand that the product of, in fact, any number of factors, two or more, means that one of the factors has to be 0. So instead of splitting it into 2, this one splits into 3. So one possibility is that that first factor is 0. Another possibility is that second factor is 0. The last possibility for here is that factor is 0. And so then, writing out all the possibilities, so that'd be w is 3/4, or w is 0, or w is 2, or w is 6. Okay, and you know, instead of splitting the equation here into two parts, we could have just factored it completely. Then it would have been 4w minus 3, and then multiplied by w minus 2, multiplied by w minus 6. It would have been 4 factors all multiplied together, and then we could have performed the split right there, split into 4 pieces. It'd be exactly the same. It's just like, I mean, it's the same thing. Like, you know, if you imagine cutting a pizza, right? With a, you know, with a thingy, you know, one of these. What is it? A pizza cutter? I don't know what it is. You can cut it, you know, one stripe at a time, but you can imagine it's some device, right? That in fact can make a crosscut like this, you know, some kind of, it's the same thing.
So do you have a preference whenever we do our homework as to how we solve this?
You mean,
I mean,
no.
yeah, I mean,
As long as it's clear what you're doing.
okay.
Yeah. All right, so now I'm going to give you an example of making a mistake so that you can see what a mistake might look like. So if you're going to copy this, please carefully copy, take note of where the mistake is. So I'm going to do two columns side by side. So what if we have, what if you came to a point that looked like this? So z minus 3 multiplied by z plus 4 equal to 0. And then by way of comparison, perhaps on a different exercise, you came to a place where it was z minus 3 multiplied by z plus 4 is 24. All right. So suppose that one way or another, you on one exercise you wind up in this position, and on some other exercise you wind up in that position. Okay. So from here you could say, well, the equation splits into two pieces. Either z minus 3 is 0 or z plus 4 is 0. All right. And then here, maybe you could say something like, okay, because the product of those two factors is 24, either z minus 3 is 24 or z plus 4 is 24. Okay, so somebody tell me about that.
So you would make it to where it's equal to 0, so you would add 24 to the one from the right?
Well, so one of these is okay and one of them is not okay. So which one is okay and which one, and by process of elimination, which one isn't? The one on the left is correct. The one on the right is just simply not correct at all. So let's consider. What we're saying is we have two things. We have two things whose product is 24. So it really could be the case that one of them is 24. And in that case, what would the other one be? Well, it'd have to be 1, right? If this one right here is 24, then this other one would have to be 1. Is that the only way to factor 24? Right? It could be, yeah, it could be 6 and 4. It could be 3 and 8, yeah. It could be 24 divided by 13 and then 13. Right? There's infinitely many ways to do it. So what I want you to see is that this is just an error. This is altogether incorrect. This is correct. The left-hand side is correct. This is just wrong. And what I want you to see about it is that the split that we're talking about requires the other side to be 0. Which is to say that it works when that 0 is there. It doesn't work when it's 24. Only when it's 0. Okay, I bring this up because I find that if I don't explicitly mention this, I find that students begin doing this and then can't break that habit. And it's just not right. Any question about it? All right. So, on the previous page, we wanted to eventually factor that quadratic there. Okay, the w squared minus 8w plus 12. All right. So I have a question. What if we make it w squared minus 8w plus, now on the previous page, this was a 12, but now I'm going to make it 11. Okay, so then it's, seemingly just more or less exactly the same thing, except instead of that being a 12, that's an 11. Now what? Now it's kind of a, if we use the same strategy as before, we're looking for two numbers whose product is what? 11, right? And whose sum is -8. So can you think of such numbers? Okay, so then I can't really think of them off the top of my head, not without a little bit of work. Are there any such numbers? There are. There are. But now here's a separate question. If you heard me say that there are numbers that do that, and you thought, no, let me give you a different question. Are there any integers that do that? Are there any integers whose product is 11 whose sum is -8? No, there are no integers that do that. But there are numbers that do that. But they're not integers. So now what we need to do is we need to figure out how to do it. Okay, so it's going to take a whole page to do it. So I'm going to switch to a new page. So we're going to solve w squared minus 8w plus 11 equal to 0. Okay, now the way that I'm going to do this is it's going to I'm just going to tell you what it is that I'm doing, but not why. And to some extent, it's going to kind of seem like I'm pulling a rabbit out of a hat. All right, so first thing I'm going to do is I'm going to collect all the terms with w, because all the terms with w are going to the party. So terms with w are going to the party, but the terms without w not going to the party. Okay. Now, inside of the parentheses there, I'm going to add something. And the thing is that what's the only number that we can add, and it won't change the equation? 0. 0 is the only thing that it can be permitted that we put in there. So I'm gonna write something that's equal to 0. And specifically, what I'm going to do is I'm going to add some amount and then subtract that same amount. So if I add 5, then I'll also subtract 5. If I add -10, then I'll also subtract -10. If I add a giraffe, I'll subtract a giraffe. Right? So whatever, as long as I add and subtract the same thing, then what I'm doing is permitted. So specifically, what I'm going to do is I'm going to add something and then subtract that same something. Okay, and that something is going to have is going to look like something over 2. So something over 2 like that. And furthermore, whatever it is that is going to be put in the denominator, we're going to square all that, so we're going to have to square that one too, because we're adding and subtracting the same amount. And the last thing I need to tell you, in order for you to be able to do this, is what are we going to put in that numerator? This number. Again, for reasons that aren't entirely clear yet. Now, strictly speaking, that number really actually is -8, but I'm just going to write 8. Why? Because in the end, I'm squaring it, right? So even if I wrote -8, the square would squash the negative, so it doesn't matter. So we're adding that much and subtracting that much, so that's a curious way to write 0, but it is 0. So 8 over 2, that's 4. Square it, that's what? 16, right? So I'm saying that inside of that parentheses there, the folks who are going to the party, going to add 16 and then also subtract 16. Curious. So now, what I'm going to do is these first three terms inside of the parentheses, those ones. So I'm going to ignore everything else and just look at those first three terms. Do those first three terms factor as a quadratic? They do. Ah. How do they factor? W minus 4 multiplied by W minus 4. So I could write it as W minus 4 all squared. I still have this subtract 16 and add 11 like that. So now I'm going to drop the square parentheses and then perform the addition. So this would be W minus 4 squared, and then I'll do negative 16 plus 11. What's that? Negative 5, right? So equal to 0. And now, W minus 4 squared, I'll move the 5 to the other side, is 5. All right. So I claim that we're starting to get into pretty good shape. Because here's the deal. Well, we're squaring something. Okay? We're squaring something. So something squared is 5. Now, if it says 5 right there, but what if I change that to like a 36? Then what must we be squaring to get 36? We must be squaring a 6. But there's an alternative. What else might we be squaring? Negative 6, right? Both of those square to become 36. And if you know, that's a 5. But if it were 100, what would we have to be squaring so that we would get 100? 10 or negative 10. So it's a 5. So what must we be squaring? What must we be squaring? So this is an important point. Okay. So again, if it says 5, but what if it said 49? What would we have to square to get 49? 7 or negative 7. And if it says 5, but if it said 81, then what would we have to square to get 81? Negative 9 or positive 9. It says 5. What do we need to square so that we get 5? The square root of 5. Or negative square root of 5. Now, to be clear, here's the problem. Is that in the first place, I have a question. The number, square root of 5. No, back up. This thing that I wrote here, square root of 5, is that a number? Yeah. It's the number that when you multiply it by itself, you get 5. That's what that number is. Now, when I write this, square root of, say, 36, when y'all, you know, I don't want to speak for you, but I'll say this, it's just my experience, that when the average college algebra student looks at the square root of 36, they take that to mean a command, a thing that you must do now, don't delay. When square root of 36 is written on the page, sort of student wants to immediately write equal 6. Okay, but it's not a command, it's just a name for this thing. Okay, so then again, the square root of 5 is a number. So it says, so I'm asking, what do we need to square so that we'll get 5? And the answer is square root of 5. Now I'm going to say something that's slightly disturbing. What if it was 36 again? What would we have to square to get 36? Yeah, but I'm not going to say that. I'm going to say if we wanted to square something to get 36, we'd have to square the square root of 36. Or negative square root of 36. And what if we wanted to get 64? Then what would we have to square? The square root of 64. Or negative square root of 64. Right? So can you see it? Good. So there's two possibilities. One possibility is that w minus 4 is negative square root 5. The other possibility is that w minus 4 is square root of 5. Right, because what do you get? What do you get if you square that? So notice, if you square the left-hand side, you get that. And if you square square root of 5, what do you get? You get that. All right. So then solving for w, we have w is equal to 4 minus the square root of 5, or w is 4 plus the square root of 5. All right, all right. So now, so that's the answer to the question. Now here, right here, basically these steps right here is where that's where I pulled the rabbit out of the hat. So this, these steps right here, that's pulling the rabbit out of the hat, but this has a name. Doing this, what's this, does anyone know its name?
Completing the square.
Complete the square. All right, good. Another thing I want to mention is that you know, we started out by asking, can you think of two numbers whose product is 11 and whose sum is negative 8? And you know, the answer was, well, no, I can't think of any numbers that do that. But then the question was, are there any numbers that do that? Well, what are they? What are the numbers whose product is 11 and whose sum is negative 8? Well, the numbers are negative 4 plus the square root of 5 and negative 4 minus the square root of 5. Those are the numbers that do it, yes?
How did you get it to equal negative square root of 5?
This?
Yeah.
Okay. Because the way that's working there is that what if we had an equation that looked like this? X squared is equal to 36. So that equation right there. Then this would split
Oh, yeah.
into two possibilities. We're squaring something and it's going to become 36. So what's one of the possibilities?
Square root of 36.
Or,
6.
or negative,
Oh, negative, yeah, yeah.
right? So which is to say that one possibility is that x is negative square root 36, or x is positive square root 36. And you know, under normal circumstances, you would just write negative 6 or 6. But do understand that square root 36, that's just a name of a number. You can call it by its other name, 6. But square root of 5 is just the name of a number. It just doesn't have the, I don't know, it doesn't have the property of having even another name that happens to be an integer. Okay, so you couldn't, it's not really possible to factor this in an easy way, but nevertheless it does factor. So we can say, therefore, as a result, w squared minus 8w plus 11 does factor, and it factors like this: w minus something multiplied by w minus other something. And it's the same thing that you've always been doing. We want these two numbers to have the property that you know, multiply to be that one, add to be the other one. What goes in here? What numbers go in here? Yeah, those two do, right? Which is to say that you know, So the numbers look like that. That's why, you know, when I ask, can you think of can you think of two numbers that do it? No, probably not. Unless you're, you know, really good at this already. Interesting. Any question about this? All right. So generally, the procedure for carrying this out goes like follows. So that procedure is called completing the square. And so now I'm going to explain to you what that means. So if we have a given quadratic equation, ax squared plus bx plus c equal to 0. Now to be a quadratic equation, it must be the case that a is non-zero. So it's fine for b to be 0, it's fine for c to be 0, but it's not a quadratic unless a is non-zero. So a could be 5, it could be -8. Just can't be 0. So now, the case that we love, because it's the easy case, is when a is what? I'm fishing for the name of the case starts with M. Monic, that one, right? So the monic case is the easy case, and what does that mean about a? It means a is 1, right? So here's the easy case. And I'm just going to look at the easy case for the purposes of illustration. So the easy case is when a is 1, which is to say that the quadratic is monic. And if you note, the way the procedure went is that this constant term, the thing without a variable, on the previous page it was 11, it was sort of left alone. And because it was left alone, I'm just going to ignore it on this page and say that it's 0. So what I'm telling you is that we're going to consider this. So x squared, because just 1, and then plus bx, like that. And I'm going to do 2 columns, left and right. So if we wanted to complete the square for this, then what we do is we say that this is equal to x squared plus bx, and then we need to add and subtract the same amount. So what do we need to add and subtract? So so it was, remember, we add this something, subtract the same thing. It'll be plus something over 2 squared, and then subtract same something over 2 squared, right? My question is that, again, what goes in that numerator? The b does, right? So then so that's b there, b. All right. Now, those first 3 terms, the first 3 terms right there, they factor, which is to say that we can write this as blah squared, and then subtract b over 2 squared, because that one stayed, and those 3 are going to become this 1. Okay, so what do I need to write in there? So because of the x squared, what needs to go here? X. And because of the b over 2 squared, what needs to go right there? B over 2. And then it has to be plus because of that plus. And you can FOIL that out and check. All right. So what I want you to see is that algebraically, what completing the square is saying, it's saying that you can take this expression right here and turn it into the difference of 2 squares, right? This thing squared minus that thing squared. Difference of squares. So that's algebraic. Now geometrically, I'm going to take this x squared plus bx, and I'm going to view it in a different way. Notice that these two terms have a common factor. What is it? X. So I'm going to factor it out and view it like this: x multiply x plus b. And there's a lot of things I'd like for you to be able to walk away from this class and know for sure for the rest of your life. But one of them definitely is that you know, when you multiply two numbers, there's a geometric significance to it. So if we had a rectangle, say like this rectangle right here, and suppose we measure it and it turns out that the base is 5 and the height is 3, then what's the area of that rectangle? 15, right? And how'd you do that? Multiply, right? So what I want you to understand is that this multiplication and every multiplication can be interpreted as the multiplication of two real numbers can be interpreted as the area of a rectangle. All right, so I'm going to draw that rectangle. So this is x, and this is x plus b. So now there's a rectangle. So now I'm gonna make a slightly different rectangle, and I want you to tell me how the area changes. So this rectangle versus that rectangle. What happened to the area? So this one versus that one. The same, right? The area is the same. That doesn't change anything. How about this one versus that one? The same, right? So what if I cut the rectangle into two pieces, and then I into two rectangles, and then I compute the area of each one and then add them together? Then what? Same. Okay, good. So I'm going to cut it. I'm going to cut it right there so that this is x and this is x and that's b. So, you know, I cut it right there so that this shape right here is a square, actually. And then this other one is, you know, a rectangle. All right, so then now I'm going to cut that strip. I'm going to cut that into two pieces. This one right here, and I'm going to cut it exactly in half like that. So if that's b, and I cut that exactly in half, then how big is that piece? Just that one. Half of b, right? b over 2. And how big is that one right there? b over 2. All right, so now I'm going to shade this one in because I'm going to cut it and move it. But cutting and moving it doesn't change its area. So the new result will look like this. Okay, now I want to measure everything. So you can see I took that piece and moved it down there. So this is x, this is x, this is b over 2, and that's b over 2 down there. All right, so now this shape, as I have it arranged, is it a rectangle? It's not a rectangle, right? Because it's got like that corner bitten out of it. But, you know, if I ignore that for a moment and then ask, how tall is it, that measurement right there? X plus b over 2. And how wide is it?
X plus b over 2.
So you're telling me that, except for that corner that's missing, this thing would be a square. You might even say that this square, you know, might be considered to be incomplete. So let's you know, I can't stand that. I'm going to fill it in. I'm going to just fill it in. Oh, and now it is a square, right? Because I fill it in. But it's got to be taken from somewhere, right? Conservation of energy and mass and what have you. So then if I put that red one there, then I'm going to have taken that from somewhere else. By the way, how big was that? How big is that red piece? What's its base? b over 2? And what's its height? b over 2? So this is b over 2 and this is b over 2. So you're telling me that this picture is saying that the result is actually the difference of two squares? And then I wrote, in algebra, I wrote those ones in red, and in the picture I wrote those ones in red? Wow. Complete the square. So any question about what the meaning of that is? All right. So now, that's nice, but that was kind of the easy case. The general case, that is to say when things aren't necessarily monic. When C is 0, when A is 1, that's special enough to have a name, monic, and we even use that in our class. When C is 0, that's special enough to have a name, but we don't really use that in our class. That's called the homogeneous case, but that's not really necessary. So now we're going to consider the non-monic, non-homogeneous case. So, given ax squared plus bx plus c equal to 0 with a non-zero a. So we want to eventually solve for x, and the way we're going to do it is by completing the square. Now, to complete the square, the technique that we're using, we did it with monic quadratics. Now, is this quadratic monic? Nah, not necessarily, because you know, it's got the a there. So I'm going to divide both sides of the equation by a. So divide the left-hand side by a, divide the right-hand side by a. What's 0 divided by a? 0, right? So now, term by term, we'll divide these. So what's a multiply x squared divided by a? X squared. And then what will the next term be? B over a multiplied by x. And finally, plus c over a. All right, so that's nice. That's nice because now it's monic. Now the coefficients are fractions. That's a little bit achy, but at least it's monic. So now what we're going to do is this is the place where we add and subtract the same amount. So specifically what it is the thing that we want to add and subtract is going to be this, right? And then what do I put in there? So I'm going to ignore this part for a second. What do I put in there? B over a, right? So like that. And then now I want to simplify b over a over 2. So you could simplify that as well. That'd be b over a, and then multiplied, instead of dividing by 2, I'll multiply by a half. And how does that simplify? B over 2a. So what I'm saying is that considering that, the next step would be to write that this is x squared plus b over a multiplied by x, and then we'll add b over 2a squared and subtract b over 2a squared, and then add c over a. Equal to 0. Okay, now we're, in the interest of time, I'm going to omit a bunch of stuff. Okay, and it won't be tested over. You'll have to know the end result, but you should try and fill this in. Okay, so omitting that part. So you keep carrying out this procedure a little bit further, getting closer and closer to solving for x. You'll get to the same kind of place like we were right here, where you've got something squared with x in it is equal to a constant. Okay, you'll get to that same kind of place. And eventually you come to this, this position, that x is equal to negative b, and then plus or minus, because there's two possibilities, square root of b squared minus 4 multiply a multiply c. divided by 2 multiply a. So that's a formula for the two different values of x in terms of the coefficients a, b, and c. And this works in all cases. Now, brief terminology here is that this thing up here, this thing is called a quadratic equation. This thing down here gives you the solutions to that equation, and it is called the quadratic formula. And more or less, you can just, once you know what the formula is, you just plug in the values for a, b, and c and just perform arithmetic, and then you have the answers. But I will mention that this thing is called a quadratic equation, right? Because there's infinitely many of them. But this is the quadratic formula. It is a formula by which you can compute the solutions. So, for some of y'all, this is in the first place, this is a formula that you must memorize. Okay, it won't be given to you. You must know it. Furthermore, this might be like the most complicated formula you've ever been requested to memorize. Okay, perhaps that's true. But even if you're a little bit nervous about that, I promise you that you can do it. I know that you can because I've got 2 kids, and they're both more than 3 now. But they both went through age 3, and at age 3 they knew this formula. Now I don't claim by any means that they knew how to use it or what it meant or anything like that. Nothing like that. But I do claim that they knew it. Because when we're in the car, we sing it like this. Negative b plus or minus the square root of b squared minus 4ac of b squared minus 4ac all over 2a, all over 2a. So you might not have, yeah, thank you. You might not have expected that on a Friday, but here's the deal. If you don't like the Frere-Jacques tune, you can also sing it to Pop Goes the Weasel. I leave it to you, and a variety of other things. I leave it to you to do that. Now here's the point, is that next week there's going to be a quiz. And this is going to be on the midterm. Okay? And you've got to figure out some way to remember it. And when you're taking the midterm exam, you'll know who knows the quadratic formula, because off in the distance you'll hear and then you'll think, oh, that person knows it. And I don't. All right, have a good weekend.